In today's video, we're going to be talking about the tree traversal algorithm of preorder. Now, before we get started, what exactly is tree traversal? Well, tree traversal is, to simply put it, a way of visiting all the nodes in a tree. And what does that mean? Well, that means possibly processing them or just simply visiting them, but as long as you do either of those, it's considered tree traversal. So we're going to be talking specifically about the pre-order traversal algorithm. And we have other videos on in-order and post-order, and they all share this three common main steps. The orders are all just different. So the three main steps in pre-order are number 1, processing the current node, number 2, traversing the left subtree, and number 3, traversing the right subtree. Okay, so next, let's look at a pre-order step-by-step example on the following decorated tree. And this tree is actually purposely decorated as such so that when the output comes out, you'll see exactly how it works. Okay, so for each of the nodes, we have 3 calls. Node, which is process the current node. In our case, we're going to output it, go to the left subtree, and go to the right subtree. Okay, so first let's process the current node, and that's node A. We're going to output it, go to the left, so let's go there. We're going to call node, so let's process it. We're going to call left, so go to the left subtree. Let's call node, which is just processing the node. So let's process it. Call left, well, there's nothing to the left. Call right, there's nothing to the right. And so as you can see, we filled all the criteria of finishing all 3 of the steps. So that means node C is finished processing. Okay, so now we're back at node B, but node B still has yet to do the right subtree call. So let's do that. We're going to go to node D. We're going to call node, process it, go to the left, call node, process it, call left, well, there's nothing to the left, call right, nothing to the right, and so as you can see, we're done with node E. So now we're back at node D, and we still have yet to do the right subtree call. So let's call the right subtree, go there, call node, process the node, go to the left, go to the right, and as you can see, we're done with node F. So we're going to discard the node F. We're done with node D as well. We're done with node B. And now we're back at node A. So now what we're going to do is we're going to call the right subtree call. We're going to go to the right, call node, process it, go to the left, there's nothing there, call right, go to the right, call node, process it, go to the left, go to the right, and as you can see, we're done here. So now that we're done, we can discard H, we're done G, discard G, and we're done with A, so we can discard A now. And there we go. We're finally done traversing the entire tree in a pre-order manner. So as you can see, it goes A, B, C, D, E, F, G with a purposely labeled node tree like this. Okay, so how exactly does pre-order code work? Well, essentially, let's assume that we have the following declaration of a node, where we basically have the current node's value, which is int val, node left, which is a pointer to the left node, and node right, which is a pointer to the right node. Then the code will look something like this, and keep in mind that this is pseudocode. So the first thing that we'll do is we're going to have a parameter header, such as void, and we're going to call it preorder, where we pass in a current node. And while the current node is null, which means it's not really a node, we're just going to return so that we don't do anything with the node. Then what we're going to do is process the current node, and we might process whatever the value, whatever things we have inside there. Then we're going to call the preorder function on cur.left, which means go to the left subtree and perform the preorder function on that. And then finally, we have preorder cur.right, which means process the right subtree in the preorder manner as well. And once all that's done, you have successfully performed the preorder algorithm. Okay, so now let's talk about the time complexity. What does the time complexity look like? Well, each node is visited exactly once. So what does that mean? Well, that just means that it's O of n, where O of n, where n, is the number of nodes that we have in our tree. And that's pretty much it for the pre-order traversal algorithm.